Hey everyone, welcome back to the channel. Today, we're diving deep into the digital world, starting with the absolute basics, data and information. You hear these words thrown around all the time, often interchangeably. Data breach, information overload, big data. But are they actually the same thing? The short answer is no, and understanding the difference is key to understanding how our digital world works. So, let's start with data. What is it? Think of data as raw, unorganized facts and figures. It's like a random pile of Lego bricks. You have a red brick, a blue brick, the number 7, the letter A, the word cat. By themselves, they don't mean much. They lack context. A single temperature reading of 98.6 degrees Fahrenheit is just data. A list of names, John, Mary, David is just data. It's raw, it's unprocessed, and it doesn't tell a story on its own. Now, let's talk about information. Information is what you get when you take that raw data and give it meaning. It's data that has been processed, organized, and structured in a way that makes it useful. It answers questions like who, what, when, and where. So, if we take that temperature reading of 98.6 degrees Fahrenheit and we add the context that it's John's body temperature taken at 9 a.m., suddenly it becomes information. It tells us something meaningful about John's health. If we take our list of names and organize it under the heading Winners of the competition, that's information. We've turned our random pile of Lego bricks into a cool-looking car. Information is data with context and purpose. So, how do we get from that messy pile of data to useful, structured information? This is where the information processing cycle comes in. It's a fundamental concept in computing, and it's happening billions of times a second inside the devices you use every day. The cycle has 4 main stages: input, processing, output, and storage. Let's break it down with a simple example. Imagine you're using a calculator to add to numbers. Say 5 and 3. The first stage is input. This is where you feed the raw data into the system. On your calculator, you press the 5 key, the plus key, and the 3 key. You're inputting the data 5, 3, and the instruction to add. You can input data using a keyboard, a mouse, a microphone, a scanner, a camera-any device that lets you get data into the computer. Next up is processing. This is the magic part where the computer's brain, the central processing unit, or CPU, gets to work. It takes the raw data from the input stage and performs operations on it according to your instructions. In our calculator example, the CPU takes the numbers 5 and 3 and performs the addition operation. It's doing the calculation. This is where the raw data starts its transformation into information. After the processing is done, we move to the output stage. This is how the computer presents the processed information back to you. The calculator displays the number 8 on its screen. That 8 is the result of the processing. It's the information you wanted. Output can be anything from text on a screen, an image from a printer, sound from speakers, or even the movement of a robot arm. It's the result of the whole process. Finally, we have the storage stage. Often, you want to save your data or information for later use. This is what storage is for. In our calculator example, maybe your calculator has a memory function to save the result 8. In a computer, this could mean saving a document to your hard drive, a photo to your phone's memory, or uploading a file to the cloud. There are two main types of storage: primary storage, like RAM, which is temporary and holds data while the computer is on, and secondary storage, like your hard drive or an SSD, which holds data long-term even when the power is off. So, to recap the cycle, input the raw data, process it to give it meaning, output the resulting information, and store it for future use. This cycle is the heartbeat of every single computer, from the supercomputers analyzing weather patterns to the smartphone in your pocket. Now, we've talked about what data is and how it's processed. But how does a computer, which is just an electronic machine, actually understand and handle all this data? It conc the letter A, or understand the number 5 like we do? The answer lies in a concept that is elegantly simple: binary. Computers speak in a language of just two symbols, 0 and 1. That's it. Everything you see on your screen this video, the text in the comments, the colors, the sounds is, at its most fundamental level, a massive sequence of zeros and ones. Each one of these zeros or ones is called a bit, which is short for binary digit. A bit is the smallest possible unit of data in a computer. Think of it like a light switch. It can either be off, which we represent as 0, or on, which we represent as 1. A single bit on its own can't represent much. It can only tell you one of two things, like yes or no, true or false. To represent more complex things like letters, numbers, and colors, we need to group these bits together, and that's where the byte comes in. A byte is a group of 8 bits. By arranging these 8 bits in different combinations of zeros and ones, we can create a unique pattern for each character we want to represent. With 8 bits, there are 2 to the power of 8, which equals 256 different possible combinations. That's enough to represent all the uppercase letters, all the lowercase letters, all the digits from 0 to 9, and all the common punctuation marks and symbols. For example, in the common ASCII standard, the capital letter A is represented by the binary sequence 010001. The number 5 is represented by 001-10101. When you type the letter A on your keyboard, you're sending that specific 8-bit pattern to the computer. The computer processes that pattern and then displays the letter A on the screen. It's an incredibly fast and efficient system of translation. Of course, we deal with much larger amounts of data than just a single byte. That's why you see terms like kilobytes, megabytes, gigabytes, and terabytes. A kilobyte is roughly 1,000 bytes. A megabyte is roughly 1,000,000 bytes. A gigabyte is a billion, and a terabyte is a trillion bytes. To put it in perspective, a simple text email might be a few kilobytes. A high-quality photo from your phone could be several megabytes. A full HD movie might be a few gigabytes, and the hard drive in your computer probably holds 1 or more terabytes of data. And all of it, every single bit of it, is just a ridiculously long string of zeros. And ones perfectly organized and processed to create the rich digital experiences we have every day. So there you have it. We started with the fundamental difference between raw, meaningless data and useful, contextualized information. We walked through the 4-step cycle of input, processing, output, and storage that turns one into the other. And finally, we peeked under the hood to see how computers use a simple language of bits and bytes, zeros, and ones to represent and manage everything. Understanding these core concepts is the first step to becoming digitally literate. It helps demystify the technology that surrounds us and gives you a better appreciation for the incredible engineering inside these devices. Thanks so much for watching. If you found this helpful, give the video a like, and don't forget to subscribe for more deep dives into the world of tech. Let me know in the comments if you have any questions. See you in the next one.